Good morning/afternoon, everyone. Welcome to today's presentation. I'm Dr. S.K. Singh, and I'm excited to share some insights with you. Today, we'll be exploring a comparison between 70% ethanol and isopropyl alcohol, or IPA. Over the next few minutes, I'll guide you through their differences, uses, and effectiveness. So let's dive right in and see what makes these disinfectants unique. Let's start by talking about alcohols and their role in the pharmaceutical industry. They are widely used for various applications, including surface disinfection, skin antisepsis, and cleanroom sanitation. These are critical areas where maintaining sterility and reducing contamination are essential for patient safety and product integrity. There are two primary types of alcohols that we typically use in these settings. The first is ethanol, also known as ethyl alcohol, which is perhaps the most familiar type. The second is isopropyl alcohol, often referred to as IPA. Both of these alcohols are highly effective, but they have slightly different properties and uses depending on the situation. A key point to remember is that the typical working concentration for these alcohols is around 70% volume. This concentration strikes a good balance between efficacy and safety, ensuring that the alcohol effectively kills microorganisms while being safe enough to handle and apply. Understanding these basics helps us appreciate how alcohols are such a vital component in maintaining hygiene standards in pharmaceutical settings. They form the backbone of many infection control procedures we'll discuss further in this presentation. Let's talk about the mechanism of action for both ethanol and isopropyl alcohol. Essentially, they work by denaturing proteins, which means they disrupt the structure of vital microbial proteins, rendering them inactive. At the same time, they disrupt cell membranes, causing the cells to break apart and die quickly. The result of this process is rapid microbial death, making these alcohols highly effective disinfectants. Their spectrum of activity includes being bactericidal, so they kill bacteria, virucidal, meaning they inactivate viruses, and fungicidal, which targets fungi. However, it's important to note that they are not sporicidal. They don't kill bacterial spores. Now, why is a 70% concentration preferred? Well, the optimal antimicrobial range for alcohols is generally between 60 and 90%. Specifically, 70% alcohol provides better protein denaturation because it contains enough water to allow the alcohol to penetrate cell walls more effectively. Plus, it offers a longer contact time since it evaporates more slowly than higher concentrations. A key insight here is that higher concentrations, like 95%, can actually be less effective because they evaporate too quickly, reducing the contact time needed to kill microbes effectively. So, in summary, 70% alcohol strikes the right balance, maximizing microbial kill while maintaining adequate contact time for optimal disinfection. Let's take a closer look at the limitations of using ethanol and IPA as disinfectants. While they are widely used, they have their drawbacks. First, they are not effective against bacterial spores, which are some of the most resistant forms of bacteria. This means that relying solely on these alcohols won't guarantee complete sterilization in environments where spores might be present. Secondly, their activity on viruses varies. They are somewhat limited when it comes to non-enveloped viruses, which tend to be more resistant. In particular, IPA has a weaker effect on these types of viruses compared to ethanol. From a regulatory perspective, this is a key point. Because of these limitations, it's important to combine ethanol or IPA with sporicides when working in aseptic areas. This ensures we're covering all bases and maintaining the highest standards of sterilization and safety. Now, when we compare their chemical properties, understanding these differences helps us choose the right disinfectant for the right situation. Recognizing their strengths and weaknesses allows us to make more informed decisions in our infection control protocols. Let's take a closer look at antimicrobial efficacy comparison. Both alcohol-based solutions are effective against a broad range of microorganisms, including gram-positive and gram-negative bacteria, as well as lipid viruses like influenza and HIV. This highlights their versatility in disinfection. However, there are some differences worth noting. For instance, isopropanol, or IPA, tends to be slightly more bactericidal against certain bacteria compared to ethanol. That means it might be a better choice when targeting bacterial pathogens specifically. On the other hand, ethanol generally shows better activity against some viruses, making it particularly effective in viral disinfection. So, depending on the specific threat you're addressing, one might be more suitable than the other. Understanding these nuances helps us choose the right antimicrobial agent for different clinical or sterilization scenarios, which ties into our overall goal of effective infection control. Let's talk about the safety and toxicological differences between ethanol and isopropanol, or IPA. Ethanol is generally considered less toxic, especially since it can be ingested in controlled amounts. Think of alcoholic beverages. On the other hand, IPA is more toxic and is not suitable for ingestion, so it needs to be handled with more caution. Both ethanol and IPA share some common characteristics. They are flammable, so fire safety is critical, and they can cause skin dryness if you're exposed to them repeatedly. When it comes to regulatory acceptance in pharmaceutical environments, both of these alcohols are recognized as disinfectants within GMP, or good manufacturing practice, settings. That's a key point because it underscores their trusted role in maintaining sterile conditions. However, it's important to remember that both substances must meet certain standards. These include pharmacopoeial standards, like those from USB or pH. And impurity limits, for example, testing for methanol contamination to ensure safety and quality. The most critical aspect to keep in mind is that both ethanol and IPA must be validated for their intended use. This means they need to be tested and documented to confirm they perform effectively and safely in their specific application. So, understanding these differences and requirements helps us ensure we're using the right disinfectant safely and compliantly in pharmaceutical settings. Let's look at the applications of these disinfectants in the pharmaceutical industry. Starting with 70% ethanol, it's commonly used for cleaning surfaces in cleanrooms, which is critical for maintaining sterile environments. It's also effective for skin antisepsis, helping to reduce microbial presence before injections or procedures. Additionally, 70% ethanol is used for viral decontamination, ensuring that surfaces and equipment are free of viruses. Now, moving on to 70% IPA, or isopropanol. This is mainly used for cleaning equipment, small surface disinfection, and even cleaning electronics and instruments. Its versatility makes it a go-to choice in many areas. However, it's important to consider material compatibility. IPA can be more aggressive on plastics and rubber, especially with long-term use. This means it can cause damage or degradation to certain materials over time. On the other hand, ethanol generally offers better material compatibility, making it suitable for a wider range of surfaces and components. For example, while IPA is very effective, it may damage some medical device parts if used repeatedly or improperly. So, selecting the right disinfectant isn't just about its antimicrobial efficacy, but also about understanding the materials you're working with and their compatibility. Let's take a look at some practical examples of disinfection procedures. First, in an aseptic area, we typically categorize the environment as grade A or B for these zones. We use sterile 70% isopropyl alcohol for routine disinfection to maintain a high level of cleanliness. Additionally, we perform periodic sporicide treatments to eliminate any resistant spores that might be present. Moving on to hand hygiene, the World Health Organization recommends using hand sanitizers with specific formulations. The most effective options are either 80% ethanol or 75% isopropyl alcohol. These concentrations are proven to effectively inactivate a wide range of microorganisms on the skin. Finally, when it comes to cleaning equipment, alcohol-based solutions are preferred, especially isopropyl alcohol. The reason is that IPA dries faster, which helps speed up the cleaning process and reduces downtime without compromising on disinfection quality. These examples highlight the importance of selecting the right disinfectant for each situation, which is crucial for maintaining a sterile environment and ensuring safety throughout our processes. Let's take a closer look at the key differences. First, it's important to understand that these distinctions really shape how we approach the topic overall. When we compare these aspects, we see variations in how they function and their impact. For example, some differences might relate to scope or complexity, while others could involve the target audience or the methods used. Highlighting these points helps us better grasp why certain strategies work better in specific contexts. Ultimately, recognizing these key differences ties back to our main theme of tailoring solutions to fit unique needs. So, keeping these distinctions in mind allows us to make more informed and effective decisions moving forward. In conclusion, both ethanol and isopropanol are effective and fast-acting disinfectants, making them reliable choices for many cleaning needs. When considering concentration, 70% is generally the optimal level because it balances efficacy with material compatibility. Choosing between them depends on several factors. For example, the application matters, whether you're disinfecting surfaces or skin, since certain formulations are better suited for one or the other. Material compatibility is also key, as some surfaces may be sensitive to certain alcohols. Additionally, regulatory requirements can influence your choice, ensuring compliance with safety standards. It's important to remember that neither ethanol nor IPA replaces sporicidal disinfectants. For environments where spores are a concern, specialized disinfectants are still necessary. Overall, understanding these points helps us select the most appropriate disinfectant for each situation, ensuring safety and effectiveness across our practices. For further support, please contact us. We're here to help with any questions or additional information you might need. Don't hesitate to reach out. Your success is our priority. Thank you very much for your time and attention today.